Is
This
Cosmo
conference
joining us
will
today?
now be recorded.
Great. So, Jaime, did you say is Cosmo joining, or is he?
Cosimo is not joining today. But Cosimo is on trip, so you can, if you want to start, Don, doing a recap.
Go ahead and do a quick start. I think most of the people have been on these calls before, but I'll run through it real quick. I'm Don Mitchell. This is Jaime. We're talking today about the heat reuse sub-project of the cooling environments project for Open Compute. And we've been in the heat reuse group came about as we started looking at the concepts of different methodologies of cooling the data center, especially with liquids. We see the potential for higher temperature and higher quality rejection heat. And in today's world, we're trying to figure out how to do that best. We also have, for those that there's a project building on sustainability. And we have a symbiotic relationship with that project. And I just had a call this morning with people on that as to where does heat reuse line up? Is it more of a facilities or cooling environments discussion? Or is it more of a sustainability discussion? The answer is yes. And what we have tentatively agreed, although we're still working through the details of this, is that for the aspects of the physical host and the source of heat and the management thereof, the physical aspects of the heat reuse project will reside currently in the cooling environments group. However, the development of metrics and measurement and motivation for using heat reuse aligns up very much with the sustainability group. And for those that are trying to understand where that fits into our world, we're also reaching out to organizations like the ICA, which is the iMasons Climate Accord, for those that are familiar with iMasons. And most of the major data center companies in the world have signed an accord saying they are going to reduce their carbon footprint and be a more sustainable company going forward. And this is in anticipation. There's European legislation, other legislations coming out that is going to transition this from being a good thing to do to a required thing to do. So we're trying to address this, and I'm going to actually hand over to Jaime, but I'm going to give a quick overview that we're looking at categorizing to a large extent the applications for heat reuse with the climates of our data centers and also with the topology of our data centers, and see where we can find synergy. And then we're looking at trying to marry that with the company goals or the global goals of sustainability and improving the energy management of data centers and the carbon offset. And with that, Jaime, I'm going to hand off to you because I think we've gotten, now people are actually interested in listening. So it's up to you.
Thanks, Don. Thanks, Don. Also, for the ones who missed that, last week we had a cooling environments call where we all made, I don't know if you all guys were there, that was last Thursday. And we all, the project leads of the subgroups inside of the cooling environments, we made a short update of what we were doing. So this is happening, Don, if I'm not wrong, the last Thursday of the month at 5 p.m. West Coast time.
The third Thursday, but yes.
Exactly. So the third Thursday. Okay, sorry. And so you're all invited to come there as well to know more also from the other work streams like the cold plate immersion work stream or the ACF, which actually also Tuesdays on this same slot, and we're sharing actually the time slot for that. So I'll start sharing my screen actually to make a short introduction as always. There's already a question here. Yeah, the recordings. Yeah, thanks, Rand, for your question. You all guys know most probably that there is a chat box there where you can write stuff. You can also just unmute yourself and just contribute. We are not so many people, so it's not a problem. But yes, I will start sharing my screen. Actually, go to our wiki page and try to answer that question first, and then continue with the discussion. So So here we are at the wiki page, our wiki page for heat reuse, and our recordings are here. Yes, so yeah, there are some missing recordings. You're right. Thanks for bringing that up, Ranan. We'll try to figure out that as soon as possible. But thank you for your comments. In any case, we are recording all the calls, yes, and especially the guest presentations. I guess you are also the most interested on guest presentations, but we are recording all of them. So I wanted to start actually by making a short introduction. Yes, we are here at the heat reuse workstream, and we have a wiki page. Just ran and pasted that in the chat box, so I don't need to copy that again. We also have a calendar, an email if you want to contact us directly. And Cosimo cannot attend today, but he's also active as a project lead in this workstream, the same as I am. So our objectives were, as always, gather information of the industry and show use cases of heat reuse in the data center industry, and also well, highlight the challenges and opportunities and see what actually we can we do with heat reuse in this in the data centers. This, I guess almost everybody was here already, but we always repeat this. So just I don't know, you can write an email in the meanwhile if you already have heard this for 20 times. I don't care about that. And what we want also is to create a community, to create to sensibilize the industry about the heat reuse, to say that it's not only possible, but it's kind of necessary. It's a good thing to have. And we also want to elaborate a white paper with recommendations for new developments. So I want also to talk about this, about white paper, because we already started writing something, putting something together. This is rather, even if we have called it white paper, it's becoming rather a guideline. And we are, you see here, we are having around 30 pages already, so it's getting very big for a white paper. And so far, we are pretty proud of what we have brought here. Nevertheless, you are all invited to have a look into that and comment. There are already a couple of people that have done this, and I'm very thankful to them. I think Aaron, you are here, you did that, and you have a couple of comments here, and other people as well. Thanks a lot for that, and also for the contributors that already have written something. So we want you guys to bring as much information and as many eyes as possible to this white paper. The white paper is accessible to all of you guys, to all the people with the link. I will just copy that here. If you can also live try this, maybe I'm wrong, but theoretically it should be available for everybody with the link, and everybody should be able to comment, not to write, but to comment. And I think this is very positive. If you guys can have a look to that and think what, I mean, and comment and be critical against that. Here is the table of contents, actually. I have a sum up version here. And this is actually what we are actually suggesting as a guideline, right? We think this is covering pretty much what we have talked, discussed, and what we can discuss, and what we can actually think about when developing a heat reuse concept in a data center. Do you guys, I know it's a pretty spontaneous question, but maybe somebody already has an idea. Is there something you guys think is missing here, or could be better, we could consider, and it's not being considered, just looking at the titles? I mean, if this is something, guys, you can in a very spontaneous way think and comment. Very open to comments. It's okay, it might be also perfect, but I don't think it's perfect. But well, in any case, if you guys want to comment something, you can always just read very slowly. I mean, I'll give you maybe 30 seconds to have a look to that, and you can maybe say something. So I just start saying that we start just describing the purpose of the guideline. Then we want to make this overview about all the waste heat reuse projects they have been developed in the world so far. So this is actually will be the first chapter to give an overview of what has happened, of what has successfully happened or unsuccessfully happened. There are some projects that they are not existing anymore, and this we also want to list them. Then we want to talk about data center waste heat, so about the definition of waste heat and what does this mean exactly. Then there is a chapter about the heat host, the different types of heat hosts. This might be, I would say, this is the core of the guideline because it will show all the possibilities of giving your waste heat away to somebody else. And so actually, as a data center developer or designer, it allows you to understand better where to look actually around the data center location or data center future location to connect your waste heat to that. So actually, for instance, heat host has a lot of subparts, and it's talking about actually the current heating sources of those heat hosts, actually how the current heat hosts, depending on which one, are actually providing the heat for themselves, what are they using. Then we are classifying them into different groups, depending on where they are located, how much quantity of heat they need, what are the temperature levels, and if these heat hosts are actually moved by some seasonality, like for example, the district heating system. And then we are going in particular to the industrial heating needs because they are a bit special, and this is something actually might be not familiar to most of us. Might need a bit of more knowledge. There, of course, you're welcome to contribute to that list of industrial heating needs, and well, I will scroll down. Actually, it's better to show what actually is we have written already. There are different industries that will need heating. I mean, I'm not sure if you guys, maybe from your past experiences or you have relatives or friends in some industries, you might be familiar to the needs of for heating from different industries. We are actually open to your comments about that. After that, we are actually going into the classical ones. So industrial laundries, wastewater treatment, etc. Those things are more, I would say, uncommon. So wastewater treatment is a heating host or a heat host that is not very well known, and where we also would like to develop a bit further. Actually, in 2 weeks, we will have a guest presentation about that. You are all invited to that. I will come back to that topic afterwards. So this is pretty much what we're talking about in the heat host section, right? And singular. So this is a singular need. So the wastewater treatment, desalination, or even cooling energy, right? So you guys, if you want to make some comment, you're free to do that. After the heat host, we want to talk about, yes. Hi.
This is Shankar. Yeah, I saw you have redundancy considerations, but
Yes.
just to explain it, maybe we should add failure modes and how to deal with them. It could be part of the redundancy considerations, but just
Failure modes.
Yeah.
I think that probably under your redundancy considerations.
Yeah, it'll be part of redundancy considerations. Maybe a subsection on what are the various types of failure modes that can happen when you using heat reuse, either with a heat pump or just a heat exchanger, or maybe maintenance.
Yeah, great. Maintenance. Okay, this is maybe maintenance is something we can also put in a different section, and a totally dedicated section.
Yeah.
Yeah. John, you want to say something?
Yes, Jaime, I had, in your high level of subjects there, one that I had worked on historically was adding thermal content, right? We have this heat that we want to do something with, but we sometimes don't have it at the level we want. Usually it's not at the level we want. So how do we improve that thermal value, thermal content? And, there's a couple techniques, at least I've used. One of them called serial heating. The other one is I was using solar as solar with some very high concentration parabolic mirrors to bring some of my content up to 600 degrees Fahrenheit. But there's some lower levels for that. The adding thermal content would add value to that heat stream.
Okay, good. Thanks. This is actually something we want to consider here. It's maybe not very well expressed, but it's pretty much how to enhance that heat with heat pumps. What you said, solar.
Well, actually, I think it could be the in-between equipment, but it may be the whole subject in your content, right? I was thinking about your table of contents, adding thermal content, but it would be, the components would be somewhere in there, the in-between.
You're in between, okay. And this is, okay. And you would say an enhancement of the temperature or improvement, or that's the point, right? And like increasing the temperature.
Yeah, anything to add thermal content, right? You just want to add BTUs, however you do it. And it could be geysers, it could be ground, it could be solar, it could be, you know, something warmer than what you have. It could be, you know, running off of a hot roof. It could be lots of ways to add content, thermal content.
Great. Thanks for your comment. Yeah. Good. So great. Anyone else? Good. So I was perfect. Thanks. Great. So I was talking actually about the different heating hosts. There is one I haven't mentioned actually, and this is one very important one, and it's a direct use of the data center. Yeah. This should be, and correct me guys if you think I'm saying some nonsense. This should be, I would say, pretty much a must, right? I mean, in all the future designs, the first heat host of the waste heat or of the excess heat of the data center should be the data center itself. Someone mic is open. Michael, want to say something? Oh no, I think it's just a mistake. We'll meet you. Perfect. Thanks, Michael. So it should be the data center itself. So the data center itself should be the first user of that waste heat. First of all, because it's a way of making smaller your bill. Second is because actually you can count on that. I mean, you are controlling your whole operation yourself, and you can count on that part of your usage of the waste heat. Usually, this part will be rather small because in a data center, the needs for heating could be considerable, but usually are rather small, like for office spaces, even for white space. If you are in a very cold location, in a very strange situation, but this can be done as well. I don't know, such as preheating gensets, for example. Gensets usually come with a preheater, electrical preheater, but why not? A suggestion would be to consider or design a different way of preheat gensets, for example.
You know, let me comment. I've been on some good sized projects. That's an excellent use. That's not one I thought about before, and whoever put that in there, I applaud. Because as data centers get larger and larger, which they are, in that, you know, the heat value that we're trying to get out of it, that generator warming, keeping the jackets warm, those generators have anywhere between 1,200 and 2,400 watt heaters on them just to keep the fluid warm, right? And then you have 100 generators in a large project, or 2 generators, not as significant, but that is an excellent use of that of the waste heat, is keeping the generators warm, because you get a 1-to-1 ratio of watts returned, at least from an electrical standpoint, because you're just generating power or heat inside that water jacket of the generator to for the quick start. And this heat reuse, I'd put that pretty far up my list of large projects. The large data centers, I'd put that generator jacket warming as one of my short lists. Yeah, it's easy to do. You're sitting right there already.
Good. And somebody else want to say something? Not be shy, guys. Well, also some usages, for example, in very cold places where there is a lot of snow, and you need to melt snow, and you can use the waste heat for that. And this can be of course very interesting. So your own use for the data center. Well, so going further in the guideline, So the next chapter was, well, how to transform that heat into something different or more usable or more interesting, such as, well, increasing that heat, as John also commented. So something, whatever adding thermal content might be very interesting. Then storage mechanisms that they will always be welcome. Yeah, mostly because the generation load, the load curve, the load profile of the excess heat will usually not match with the needs of the heat host. So there will be a perfect way of decoupling both systems. And then there are these two singular, but you also find them in the other chapter up at the heat host chapter. But this is actually it's not really the heat host. It's actually we want to make like here a bigger sub chapter about these special machines. So desalination or wastewater treatment machines and cooling machines.
Have you considered at all fuel cells?
Fuel cells is a good point as well. This is something actually we rejected at some point, but it might be very interesting. Actually, Shlomo, thank you very much for your comments, because there is one comment.
Fuel cells, it's a beginning now, but it's a very interesting backup technology instead of generators. But if you use fuel cells for backup, the fuel cells are going to generate a lot of heat in the process that could be recycled.
Yeah. Thanks for your comment. Actually, here, somebody I think is Aaron. I think Aaron, you are where I think he connected before. Not sure. He's still on the call. Perfect. So he made a great comment about on-site are using waste heat for on-site power generation via organic Rankine cycles and additional on-site cooling gas option. Aaron, could you maybe, if you can, comment on this?
Yeah.
Sure. Yeah. I mean, the idea behind it is that you could, it's if you have you can use an organic Rankine cycle to use low-grade waste heat for power generation. It's not very efficient, so it's probably not the optimal way of doing it. But the idea is that you could produce supplementary power that could even go back into the IT equipment. It's all, it's in theory. I don't think anyone's done it in practice yet. The other thing is that with the low-grade waste heat, you could run it through an absorption chiller to create cool or cold water. And with that, you can actually put it either back into cooling the data center. And I agree with your notion that any sort of waste heat reuse, #1 priority should be on site. And then, so if you could reuse that cooling water on site, that'd be great. Otherwise, I think I'm seeing more of the district cooling networks idea starting to become more and more popular. So there may be something there as well.
Have you seen an example of power generation using waste heat from other industries with in some other locations, or do you have some example maybe?
I don't know. I'd have to look it up. I have to dig into it a little bit, but I imagine that there's been some. I mean, I know there's been academic studies done on using organic Rankine cycles for low-grade waste heat, but I don't know if any has actually been implemented in industry yet.
Okay, I will not hear examples because this might be fantastic to have one of them. Maybe we can also contact if there is a use case of that in another industrial field. We could contact them to get some insights because they might be very, very interesting to see how we can adapt that for data center industry.
Sure. Yeah, so I'll take a look into that.
Thanks a lot, Aaron. So actually, fuel cells or this Rankine cycle. So I will put here C comment below, which is very interesting. Thanks, Shlomo, as well. So cooling machines is what pretty much Aaron also commented about absorption machines using waste heat for doing cooling energy. There are absorption and adsorption, so different methods and different temperature levels. So we can actually here develop both. Is there some other cooling machines using heat, guys, that you know, some other process? Okay, I will assume that
maybe thermoelectric generators.
thermal electric generators. Okay. Do you have an example? I mean,
not on large scale, but there are these. I'm struggling to describe it, but it's essentially solid state with two cold plates and a special material in between that generates electricity directly, if you know what I mean.
yeah, I think you know. I
It's
know what.
called that's a Peltier junction, isn't it?
Yes, that's the one.
Yes. You know what you mean. Well, don't be afraid about the scale of the other examples, because actually we want here in the OCP to talk about different scales of data centers. So even for a very small edge data centers, this guideline can be interesting. So and for those cases, we might have also very high temperature. So it's just if you guys have in mind some small scale examples in other industries, then they're all welcome.
I have, this
Yeah.
is Shankar again. So this, I have seen this before, but this is at a academic setting. So what is it is you use the heat. This is even for a low grade heat. You use the heat to store in a mechanical deformation, and then when you need to use that heat, you basically reverse the deformation of the material to get electricity out of it. I don't remember what is exactly it's called, but I can find and I can put it here. But it's basically use the heat to deform the material, and then when you want the power, use the heat, reverse the deformation of the material.
Okay.
I can.
Is it like a bimetallic material?
Yeah, it is a bimetallic material. Yes.
Yeah, there's a process, I think, well, there's been several, but there's a wax. There's essentially it's some kind of capacitor or generator that sits in a wax, and the wax absorbs and holds the heat.
That's more, yeah, that's more like that's more like a phase change you're talking about, I guess.
You know, the phase change isn't the power generator, the wax, and the wax is a phase change, but in this case, it's a stored heat or thermal storage.
Yeah.
And it's around this generator that I think you're describing, or at least the application I've seen. And they're, to your point, fairly small scale, like in the 55-gallon drum capacity. And they have these small generators in there that are about the size of a medium-sized coffee can. And they've got their components in there, and they absorb the heat from the wax, and the wax absorbs the heat from the external source. In this case, would be the data center fluid path or air path.
Yeah, right.
If you can write the name of the process, we'll be very thankful.
Yeah, I'll find it and put it in here. Yeah.
Thanks a lot. Good. So that was actually about this part of the guideline. Yes. So then we're talking about redundancy considerations. Yeah, we already had a small discussion here 1 month ago where we were thinking about how can be the redundancy influenced by coupling both systems, right? How can we actually consider redundancy or considerations, for example, at the heat host? If we have a high tier data center connected to a heat host, usually the provision of heat will be very secure because the data center must never fail, and of course it will deliver different amounts of energy depending on the day, depending on the time of the year even, but there will be no downtime almost. I mean, we're talking about tier 3 or tier 4 data centers. We're talking about 99.98 something above, and this is most probably more reliable heating source than a normal boiler or than something else. Insights in this? Good.
Well, Heidi, let's talk about that for a second. This is John. So historically in the States, to your point, the data centers are in that category, but what I found in some of my projects globally is that some governments require you to do forced electrical maintenance. And sometimes that electrical maintenance may be upstream that you can't control and or longer than your generators, or you have to do your own equipment. So in some regions of the world, you may be forced to do a downtime. Now, you may shift your IT load to another country or another data center, but that data center may be cold in order to meet some regulatory requirement.
Okay, so this, of course, is there. And there are also plenty of data centers that are still under a way of tier class. I mean, they are even for some HPC data centers or some AI data centers or cryptocurrency data centers, they don't have any high redundancy system. So I mean, they can the heat host cannot maybe rely on that heat source if it's a critical heat host, such as, for example, a hospital or whatever. So this is just the thinking about that. But if you are thinking about maybe a huge swimming pool, maybe they can live with some downtime sometimes. Yeah,
absolutely. But I just want the caveat there is that in different parts of the world, there's regulatory requirements for electrical shutdown and maintenance, and so the IT load just gets shifted to another data center theoretically. So the IT never goes down from a user standpoint, but the load may go down in that facility.
Yeah. Okay. I note what you said as well. So I'm noting what you said, guys, to make some minutes of meetings afterwards. Yeah. Sorry. No,
yeah, just to comment on the wording. I think redundancy. The word redundancy really doesn't cover everything you want to talk about. I think redundancy and availability might be a better, better title.
Alternate.
Yeah, because availability of either the source or the host is important.
Well, ironically, you may put a boiler in that string to keep the heat load up, depending on your contractual requirements.
Well, and on the data center side, you can't necessarily rely on the host, the heat rejection, because it's out of the data center's control. So, it may not be a good way to, you may not be able to save first cost because you have to put in backup heat rejection at the site, at the data center. Unfortunately.
Exactly. Except, for example, if you are thinking about these really data centers with a low availability or without any backup systems, maybe a district heating system might be very reliable for them. I mean, I'm thinking about I'm trying to cover all the spectrum. Of course, not classical data centers, but in some places, in some data centers, this might be even a plus for a data center to have a district heating that's always, and contractually, we always get heat from you.
Sure. But, on the data center side, you might have to think of it sort of like a utility. It's there, it's very reliable, but it's out of your control.
Yeah, then you need a backup. Yeah, of course. But exactly. So that's actually what this section is talking about just that topic that we think is interesting to cover. For everyone, I mean, here in this session, everybody is pretty knowledgeable about this, but the idea is to open that for the general public and for the developers and some people that might not have any ideas about what the data center is or where it's like. So that's why also this might be very interesting also to be a part of the guideline. So so that was about the redundancy. Then carbon footprint. This is also something that had a bit of controversy as well. There was also a comment here from Jeroen. I don't know if he's here on the call. Oh, he's not on the call. Well, Jeroen made a presentation, I think, in the immersion workstream about scope 4 emissions. So that was, and maybe if I'm interpreting that wrong, sorry, Jeroen, if you're not here and you're seeing this recording. But what I understood from his presentation and also his comment, which he already has written here in this guideline, is that there would be scope 4 emissions for those emissions that are avoided somewhere else. Yeah, like a fourth scope that goes totally separate from these scopes. And this would be, for example, if I am delivering this waste heat to I don't know, a heating plant, and this heating plant is avoiding to burn gas, then those emissions that are avoided from that heating plant would be the scope 4 emissions of my data center. And well, this in our opinion, the ones who have written about this here already, doesn't have to be correct. I mean, it's just a different point of view. Those emissions belong to the boiler, or belong to the heating plant. So it makes, from our point of view, no sense to consider those emissions as part of data center emissions. Data center can say, hey, I'm helping others to reduce emissions. I'm helping actually the global balance of carbon emissions. And I might try to trade with that, with the heating plant. So saying that I'm making you to avoid those emissions, I want something for that. Insights here, guys? You agree, or is something that what did I make it clear? Somebody try to talk? No? Well, so nobody wants to participate here. It's okay.
Yeah, no, one comment about that. Not only carbon reduction, but water use reduction might be a good credit. You know, if you're using water for heat rejection, normally you're not using those cooling towers.
Water usage reductions or reductions, huh? Okay, this is good. This I think this deserves maybe a different chapter. What do you think, Tom? Because
well, it's just taking credit for things you're not using,
yeah,
or the heat
great.
host is not using. So
no, but this is great. Thanks. I mean, there's something actually we have skipped. I mean, we have a part about metrics, and we talk about water usage effectiveness, thanks to the NRL people that has have made that section. But we haven't actually talked about water usage avoidance or whatever. I mean, the same way we are talking about carbon footprint or carbon emissions, water is a very important topic. Yeah, definitely. Some other opinions, guys?
I guess I can throw in my opinion about the water. I kind of talk about it later on, but I think the reduction in water is important, but it's important from the environmental standpoint to look at water scarcity footprint as the equivalent to carbon footprint, not water itself. The idea behind that is that the environmental science community has looked at water scarcity footprint as their kind of equivalent metric when you compare that to a carbon footprint, because the water scarcity footprint takes into account the amount of available water. So in other words, it doesn't matter if you use more water if your data center's in a rainforest, but it does if you're in a desert. So that's where that kind of concept comes from.
Okay, so and how would you? I mean, this is your comment was at the bottom of the guideline, right?
I think it comes around a couple times. Yeah.
Yeah. Okay. Here.
I disagree with the NREL. You have water as the ultimate environmental metric to be looked at, or WE to be as the ultimate environmental metric. I look at water scarcity usage as the ultimate environmental metric.
Okay. Okay, but at the end you use water usage effectiveness as well. I mean, it's not that water usage effectiveness you think it just doesn't depict the reality, right?
It doesn't give the entire story.
Okay.
If the goal is to look purely from a sustainability point of view, then I look at water scarcity usage effectiveness, our term. But water scarcity footprint is a more general term. To me, it's the equivalent of, if you're talking about sustainability, you generally talk about CUE over PUE, right? It would be the equivalent. If you're looking at sustainability, you should look at WSUE over WUE. WE should be looked at more as what's your water savings in terms of operational costs, whereas WSU would be what's the direct impact on the environment. And the same thing with COE and POE, right? POE is more about your power costs, whereas the COE is about what's the impact on the environment.
Yeah, great, thank you very much. I think this is rather a topic of metrics. I think we should put this into this section here. No, sorry, into this section here about metrics. Do you, just as a matter of, I'm curious, do you talk about that in the sustainability workstream, the OCP?
I've not been on the sustainability working group yet.
Okay.
Yeah.
Okay. I think that it's starting right now. It's still a bit small. If I'm not wrong, maybe Don can correct me. But this would be great actually to, maybe to open a small discussion there. If you have the occasion. In any case, our aim is of course not to go very deep into these details in this guideline or white paper, and make a reference to the others work streams and to the other white papers that should result from other work streams. So nevertheless, we have always to talk about that to make a complete work, and that is solid and not always need to go somewhere else to check. So, well, thank you very much for your insights.
So these discussions are very applicable to similar discussions that are going on with our sustainability project, which, by the way, we are looking for a co-project lead for sustainability. And the sustainability side, our sub-project is actually trying to, like I said before, partner with the iMasons Climate Accord as well as other industry organizations on the directionality of metrics and how we apply those to data centers. And I liked the discussion here on water scarcity because obviously WUE is getting a lot of attention, but to the point being made, while in a large percentage of our world, WUE is a very critical metric, there are places where it's not as critical. But it's definitely changing the footprint of our data center design. So those that are interested in this metric aspect, it will be something I think we're linking up, but I think to a large extent it'll be covered. The sustainability group is going to be pushing this, and we will be linking their content into our products and vice versa. I don't know, Jaime, what are your thoughts on that? It's a
yeah, definitely.
We definitely need to harmonize metrics. We can't each have our own sets.
Yeah. So I will talk to the people from the sustainability group to see what they are actually doing in the metrics topic, and talk about this new metric brought by Aaron. What new for me, maybe not for others, and see how we can maybe leverage that.
But one thing that was talked about is maybe on a monthly basis or thereabouts, having someone from the sustainability group give a metric update on how they're progressing or how the industry is progressing with the data center side. And we also had participation with the Green Grid in these discussions. And the challenge the Green Grid has is they no longer own the ISO standard that defines PUE, and it's getting hard to change that, but there is some movement afoot there as well, and we do not want to be stepping in. OCP is not going to be creating new metrics. We're going to try to harmonize the industry's metrics into what we share, if that makes sense.
Definitely.
And I will reach out to them as well, let them know about, because this metric is, it's something we came up with within the last year within our academic research group. So this is very new. So I'll talk to them about it and see if they'd be willing to adopt it for their documentation.
Again, with any metric, and I applaud the effort. The key thing we don't want to do is create, well, there's nothing worse than a metric that no one knows about. It's basically useless. And then there's maybe slightly worse than that is having multiple metrics that all do the same, almost the same functionality, as in it just doesn't help the industry. So no, I appreciate the work there. Thank you.
I agree. All right, thank you.
Fantastic. Good. So having discussed already about the metrics, so the next chapter is to talk about the stakeholders. I'm wondering if this chapter should be much larger and describe them a bit more. So also to help people to identify them better. Some of them are totally, I would say, logical, like utilities or so on, but not others, and especially about the heat host. About the heat host we have talked already, but this chapter, I think the idea is to just present in a short way at the end the ones getting this guideline, they will open that and maybe just jump into one chapter or the other without maybe reading the rest just before. So sometimes the information might be a bit redundant, but we think this brings a bit more quality into the work. And then the idea is to talk also about regulation subsidies that are this, of course, hopefully it will be outdated very fast because this will be changed after publishing this guideline, because it's actually is a living thing. So if you guys are aware of subsidies regulations in your country, state, region, or whatever, we also are welcome this information. There's some information about Netherlands, Singapore, Ireland, about the moratorium of building data centers. You please send us, and if you have this information, as maybe you can send us also offline via mail, like the colleague from Danfo said up before about this process, turning the waste heat into electricity or deforming materials, and he will send us that per mail. Send us also the information you believe are interesting for us in mail. And then the end is just to talk about monetization, how we can just monetize the waste heat. It's more, I would say, more a business part of the white paper, of the guidelines, sorry. And also the agreements with external partners like utilities and so on. How could you agree, and give some examples or ideas about that? Exactly. So that's pretty much the overview of the guideline we are actually preparing, and this is what one of the outcomes from our workstream. Since we know this can be a very large document, we are preparing a short version of it, and this would be a real white paper. I mean, 3 to 5 pages at the most, with a very compact information. And we might have this finished before this guideline, so we can start like as an appetizer and so on. If we are good at that, we might be able to also to present that at some point in the OCP summit, and it will be a bit challenging. So I don't want to promise anything, but we will actually try to just take this information and compress that into a small document. And also ask for feedback, guys, if you can. I guess this is something you can also participate easier than in such a large document. And this we will announce that as soon as we have it. Some more comments before I just, well, we have still 10 minutes. I could show a couple of things more about, yeah.
Hi, mate. Jimmy here. Sorry I
Hi,
joined
Jimmy.
late, so I might have missed it, but I'm just curious to know, are we considering acoustics as well?
Are we considering, sorry?
Acoustics, the noise pollution or the acoustics, because
No,
with the
this is
reduction
good.
in heat pumps and other components, other moving
Very good.
components, we may consider that as well.
Very good. Thanks. Fantastic comment. I will write it down here to see how we can introduce a comment about acoustics. Acoustics pollution, right? All right. Let's see how we can, what can we write there? Okay, and you're welcome to suggest stuff and write stuff if you want. I mean, you have also access to this white paper. You can make a comment here and we can consider that. So thanks for your comment.
Sure. And one more comment about the I know this is not completely sustainability, it's just the heat reuse. But if we are considering the liquid cooling technologies for the consistent heat reuse, uh, there are some of the benefits that we may consider which are not the part of this. For example, because of the high performance computing leveraged by the liquid cooling technologies, people are working, let's say working from home, for example, right now, right? So some of those benefits which are not being claimed right now by the companies or the corporations are not the part of the regulations, but we can also add those things as a part of the recommendation or consideration, like because if people are working from home, they will not have to travel, right? So the direct emissions through the vehicles will not take place. I'm just thinking out loud. I know it's not the sustainability workstream, but I'm just thinking how can we uh, incorporate those kind of recommendations here as well. But that will be completely a holistic approach because now they're working from home. So it also affects their erratic working hours and their ergonomics, and because they're sitting on the chair. So up to what extent do you want to go? But if you want to consider like as an indirect benefit of eliminating those kind of emissions, we can consider that.
Okay, this I think is well about home office and using the data from data center and so on. This is your comment, or this was just
Quick suggestion is, let's say because of the high performance computing and this cloud computing, we have like Zoom,
okay?
Azure, Oracle, and other platforms, right? So people are
Yeah,
working from home,
yeah.
which can eliminate direct
I
emissions
think
through the vehicles.
yeah. Thanks for your comment, but I think this is goes far away from the topic here we're discussing. Is a very general topic about the data centers themselves. As they exist, so they generate less emissions at the other side. At another side, they generate more emissions at one side, but less on the other side. But I would say that belongs rather to
Yeah, I
sustainability.
thought so, and that's the reason
Yeah,
I said it's more generic than
yeah,
the heat reuse.
exactly.
But
Exactly.
I was just trying to, I was just thinking out loud, how can we incorporate that with the
No problem.
uh,
No problem.
net carbon zero thing or the emissions part?
No problem. Thank you very much for your comment. So the next steps we are planning is well to continue with this work, guys. So keep hearing stories. The next one is next call is in 2 weeks, and we will have Arcadis and tomorrow Water here having a presentation, doing a presentation about their concept, their combined concept of wastewater treatment and data centers together as one. So they are, I mean, here I can make some copy paste from this article if you want to read, guys, to have an appetizer of what's coming next time. We will have specialists from both companies here at the OCP talking about what they have in mind. They already have some use case, but they want this to develop further. And this is a very interesting approach because they want to combine both at the same site. Actually, if you, in my opinion, is a brilliant approach because you can come to the, I would say, urban planners or authorities and say, hey, do you think do you need a wastewater treatment in your area? Yes. Do you need a do you want a data center maybe, or do you know somebody that wants to develop a data center? Let's bring both together. There is a huge synergy from both that we can profit from. So they are actually in 2 weeks coming here, guys. You're all invited. There will be a LinkedIn event that will be shared as soon as possible, so you guys can note in your calendars. 6th of September, 5 p.m. CET, 8 p.m. West Coast time. You guys all write down in your calendars. So the next thing I wanted to mention it was the OCP Global Summit. I think already Don pasted some link in the chat. So there is here, actually I have it already here. So that's the schedule of the OCP Global Summit, the detailed schedule. And if you click on here, you have the cooling environments sessions that we are actually having during the 19th of October in the OCP Global Summit. This time is only presence. There is no online attendance. So you can only come by to San Jose in California and visit us. We'll have a lot of discussions here. And about heat reuse, there will be a panel discussion at 4 15 p.m., where we are going to talk about heat reuse as we are talking here.
So for those of you who have not participated in an OCP Global Summit, it is not a trade show or a typical trade show. It's a very intense presentation of content that has been developed and approved. And you'll see these time sessions. Literally, you're talking 15, 30 minutes. It's just here's what we've got. Here's what we're going through. If you are trying to understand more of what's happening in the evolution of the industry, in one day you will get the highlights and the opportunity to meet with some of the key authors and leaders that are trying to put this together. And also, we would love the opportunity for you to participate as being those key authors and contributors. So it's not a virtual event, but it is fairly intense. And there is a trade show floor where typically it's populated with, and you can go on and see who's attendees, but last year's event, you had Microsoft displaying their partnerships with Liquid Stack, and you had Meta. Literally, it transformed from this company called Facebook 8 days prior to, and they had totally rebranded, but they had products out on their floor looking at air, ways to integrate liquid cooling into air environments. It's a very intense show, very educational, and we'd love you to contribute or just to participate any way you can. Sorry, I didn't mean to interrupt there, Jaime.
No, please. Thank you very much. I mean, we needed that information. Thanks a lot, Dan. So I think this is pretty much it. I mean, we still have 2 minutes if you guys want to say something. Otherwise, I think we can stop the recording and be sincere.
Go ahead and stop.